Mr. Daniele, coming from Italy,
Hello,
Florence.
everybody.
Hello, dye-synthesized solar cells. We're going to do some chemistry. Please applaud him.
Hi, everyone. My name is Daniele. From Italy, and I'm a chemist. Chemist is a person that create new material, or maybe sometimes he just make a smart use out of those that he finds around him. So picture yourself, for example, that you are on a summer day, a very hot summer day, the ones we have in Italy actually, and you just have some, for example, blueberries. So you could bake a cake out of blueberries, but maybe the only thing you want is to have a fun that cools you down. So a chemist can help you on that, and these blueberries will be helpful on this. So to power our fun, we just need a bit of energy. Where to find energy? Well, it's all around us. It's all around us. There's a lot of sun. And sun shines a lot of energy. Imagine if you could burn down all the gas, oil, and coal remained in the whole earth, you would get the same amount of energy in just 20 days of sunlight. It's a huge amount of energy. And the only thing we need to do is to learn how to use it. So, where should we start from? Maybe from nature. Nature does have its own way to use energy, and it does that with photosynthesis. It converts solar energy into chemical energy so that it can store it in sugars and the plant will be fed. Well, a chemist instead can teach you how to transform solar energy, store it into chemical energy, and then turn it again into electricity. The device that is capable to do this, solar energy to electricity, is called the solar cell. But since we will use a dye to store the energy, we will call our device dye-sensitized solar cell. So, there we go. So we just need to see how these solar cells are made. Show me how they are made. Please. No, just don't touch it. Yes, we just need to know how they are made of. So first of all, we have a conductive glass, a special glass. On it, we spread some titanium dioxide, and we will see what's that. Then we attach on it a dye, the core. On the other side of the cell, we will have another electrode with graphite. We fill the cell with an electrolyte, and then we seal it. And we have our solar cell done. Let's point out some of these components that maybe you're not so familiar with, or you think you're not. So titanium dioxide is the things that makes your walls white, and it's also in toothpaste. While the electrolyte is just an iodine solution, which is the same stuff you use to clear your wounds and makes your skin yellowish. Then finally we have graphite. Well, but this, I guess everyone knows where to find it, right? You have graphite in pencils. Fine? Okay? So now that we have seen all this part, I will go to the dye, which is the very core, because it's capable of harvest light and turn it into electricity. We could either use an organic dye, for example, anthocyanins, and we have them here in blueberries, or maybe we want to use an artificial dye, which means that it's something that has been made right on purpose by a chemist. So, now that we have seen all our components of a solar cell, we should go on and see how to build it up. So we have a conductive glass, and we need to test which is the side that is conductive. Beep. I don't know if you hear that. I'll make it loud for you. So we stick it to the floor, we stick it to the bench with some plastic tape, and we cover the edges like this. And now we need to spread on it some titanium dioxide. I have it on a slurry, which is this kind. I put it here on top, and I slide it down like this. So I have a thin film of titanium dioxide on my glass. Now I need to remove this glass from the bench because we need to bake it. Yeah, we need to bake it because now it's just a thin layer, and if I scratch it, it goes out. But if I burn it down, I will remove all the components that we have. We burn it to 150 degrees to remove all the solvent. Then we go to 350 degrees to burn down all the organic compounds that I have here in the slurry. Then we finally reach 450 degrees so that the nanoparticles of titanium stick to each other and stick to the glass. So now we need to let the glass cool down very slowly, otherwise it will break. And as you can imagine, this would take a long while. So as in every good cook show, I have it already done. I have it baked for you, but don't ask me to taste this, please, like in cooking show. We can instead eat this. These guys, we can eat them, but for our purposes, we're not gonna eat them. We need to smash them down so that we obtain kind of a jam of berries, and we deposit it on our glass so that it can absorb the color like this. We could do the same with an organic dye made right on purpose, an artificial one, but in that case it would take a long while. So once again, I have it already prepared. We have the two glasses already dyed, one with the blueberries and the other one is made with my own dye. So, well, next, we need to close this cell. So here is the dye, the titanium dioxide layer dyed with our artificial dye. And now that we are done, we just need to close the cell. So what we need is to have the second electrode, which is made by graphite. As we said, we all know where to find graphite. We just need a pencil to draw in this guy here and to make it black. Once you have it black, we pour some electrolyte in it. We cover face to face the two electrodes like this, and we close them up like this. Done. Let's clean it a bit. Okay. Our solar device is prepared and ready to function. But how does it function? Let's see. So to see how does the solar device function, I need to talk a bit about electrons. So electrons are these small charged particles that can be in every part of our device, in every part of our solar device, and they can move around. But they need to lie on certain energy levels. Electrons behave like balls on the stairs, and stairs are the electronic levels, so the energy levels. So if you have an electron on a high energy level, he will try to roll down all the stairs, reaching back the ground. But what happened in dye-sensitized solar cells? Well, we said that the dye is capable of absorbing energy, absorbing light. So when it does that, the electrons at the ground state, goes up to the excited state. From here, it can roll down into the energy level of titania. Here, it goes down, it goes out the cell, and it runs into an external circuit, giving its energy, so that it reached the last step of its stairs, there, into the electrolyte, and it can roll back in the ground floor, which is the starting point, so that this whole process can go all around once again and many times, creating what we call electricity. So we have seen how does they work. We just need to see if they work. So I think I have my device ready. I need to plug in something like a fan, maybe. Where's the light? There it comes. I don't have sunlight, but I hope this will work as well. Yay! I made it. Thank you all for the attention, guys. I hope you enjoyed this.